Hi, everyone. Welcome to Crossroads. I'm Alyssa, and I'm going to be your host for today. So Crossroads is presented by Cross Labs, and we are supported by Cross Compass. That's a lot of cross. So I'll break it down for you. Crossroads is our monthly fun forum where we invite people from all over the world to talk about many different topics. Because at Cross Labs, we're very interested in things like intelligence, what are living systems, how are they different from non-living systems, and how that translates into new kinds of technologies that we reimagine completely different from what we see today. Cross Compass is a leading AI technology company here in Japan. And altogether, we are at this intersection, hence the cross, between science and research and translating that into technology that transforms our daily lives. So today we have Sam Arbesman with us. Sam is just about, or actually you just have a new book that just came out called The Magic of Code, which is going to be so much fun to talk about. But he is a prolific writer. He's a mathematician and he has a blog and Substack called The Cabinet of Wonders. I've been reading a lot of his work for many, many years, and I think that we're going to have a really exciting conversation about the many things that he's been exploring lately. And I hope you can all join us for a great conversation. There's going to be a Slido, which I will post in the YouTube chat. And you can also just drop your questions straight in the YouTube chat as well. So while we're going to be talking and having a conversation together, please feel free to join us live as well. All right, without further ado, hi, Sam, welcome.
Hi, thanks so much. This is exciting to be chatting with you.
So nice to see you. Currently, you're in the US, right?
Yes, I am based in Cleveland in the United States, so in the Midwest.
That's amazing. So we're having this live conversation, completely opposite ends of the planet right now, thanks to technology and code.
Exactly. So we're living it. Yeah.
Exactly. Well, thank you so much for joining us today. Really excited to be talking about all these different things, all these exciting topics, and I can't wait to get started. I guess maybe, do you want to give an introduction for yourself, for the audience?
Yeah, sure. So, and as you mentioned, yeah, I kind of have this background in applied math and complexity science. I have a PhD in computational biology, so I actually got my start in evolutionary biology and kind of computational mathematical modeling related to that. Kind of slowly shifted more into complexity science more broadly. And then after a PhD and postdoc around these kinds of things and thinking about the future of science and technology, I actually left academia, spent several years in the foundation world. So I work for the Kauffman Foundation. And I'm currently the scientist in residence at Lux Capital, which is a venture capital firm with offices in New York and the Bay Area. So I am in either one. I've been remote for the entire time. I've been with them for about a decade now. And we invest in topics that are kind of in the emerging tech or deep tech or frontier tech kind of space, whatever we want to talk about it. The truth is, the probably more accurate way to describe it is we're kind of at that like intersection between the real world and science fiction. We're kind of trying to take all these kind of crazy things and AI and robotics and outer space and biology and turn them into reality. And so my job is not as much on the investment side. It's more about, so I'm not doing the investment. I'm really surveying the landscape of science and technology and finding areas or individuals or communities that are, or topics that are kind of at that frontier that we should be involved with, and sometimes connecting them to the companies we've already invested in. But a lot of the times it's pretty far upstream from investment. So kind of like laying the groundwork for what the kind of areas that we should be thinking about that maybe we want to invest in several years down the line. Or sometimes even areas that might not necessarily ever be good investment areas, but they're just groups of interesting people. And so I kind of try to bring them into the orbit of Lux in various different ways. But one of the most common things that I do is I spend a lot of my time speaking to the public, engaging with the public, writing. And so, yeah, so I do a lot of writing and speaking about various different areas that I'm kind of thinking about.
Oh, amazing. That sounds like an incredible journey and a lot of fun. I bet you get to see some of the coolest stuff.
Yes, it is. It is pretty wild. It's a lot of fun. Yeah, I feel very fortunate that I kind of get to just explore all these different things, write about them, and just see all this like wild stuff that really is pushing the envelope of what is actually possible.
Could you share a bit with us what you have, what you would describe as like science fiction technology and some of the most wild things that you're seeing? Are you allowed to share?
Yeah. So there's certain things. I can tell you about some of like our investments and things that we've done. Ones that are kind of maybe like not quite, and things that have been announced, or maybe they're not quite as science fictiony. But certainly, we're doing weird things, kind of like the frontier of like AI and robotics, and so just the idea of like embodied robotics or embodied AI. That is one area that I kind of never like. You kind of like think like, oh, like Rosie the robot from the Jetsons or various other things like iRobot and stuff like that. Like that feels very far off. And then when you see some of the things that these companies are doing, you're like, oh, maybe it's actually not nearly as far off as I realized, which is kind of exciting. But then, we have another company that's kind of like a very different sort of science fiction-y thing, which is, and so this is almost like, I don't know, like comic book science fiction of like, you have like, I think they would not want us to talk about like X-Men and superheroes, but basically the idea behind it is, obviously there's variation among humans. Like, so some humans are taller than average, some are shorter than average. There are some, there's kind of like normal variation, but there's also like extreme outliers. Like, so some people who like need to sleep very little or like basically not at all. Or there are populations that metabolize fat completely differently. And these are extreme outliers. And so the question becomes, like, can we actually find these extreme outliers, these kind of X-Men, and then use that as kind of the basis for developing pharmaceutical assets or trying to kind of understand humanity and human biology better. And so this is also very science fiction-y and weird. And that's another one that we're kind of playing with as well. And so we have a company called Variant Bio that has been doing this kind of thing for a number of years, actually trying to like scour the globe and find these human like physiological outliers and try to actually use that to understand what are the true extremes of human biology, which is kind of wild and feels very much like science fiction.
Amazing. That sounds like that really does sound exactly like science fiction, but brought to life by this magical thing called science and technology and research and things like that. And it sounds, to me, it's very encouraging to hear these kinds of examples and these kinds of stories, because there's obviously a lot of problems in the world today, right? But there's also at the same time a lot of solutions, which is really, really nice to hear. And I guess you personally, what are you like the most excited about in terms of like when you think of something that needs to be addressed like immediately? Like what's like one of the first things that comes to your mind?
Oh, addressed to me. And in terms of a problem to be solved, so this is not quite a problem to be solved, but it's almost like I guess the way to think about it is almost like a tool to hopefully solve all the things that I can't even imagine. And so one of the things that I think a lot about is, I guess kind of related to code and software, is the fact that like right now, most of the software that is being written for like large groups of people requires a great deal of professionals. Like you need software developers, and you often get a huge amount of funding, and that's fine and that's great. And like obviously, a lot of our companies are doing that kind of thing, but like ultimately, I think there can be a lot more possibilities when like when software and like the creation of software is actually democratized, when like people can kind of build the kinds of software they want without necessarily having to worry about hiring huge numbers of people or raising lots of money, where they can just kind of build the thing that they want, maybe as a one-off or for their specific use case. And so there's the novelist Robin Sloan. He has this great essay where I think the title is something to the effect of like, an app can be a home cooked meal. And this idea is like you don't have to be making software for a huge number of people. It can be made for you or for your loved ones in the same way that you make a home cooked meal, as opposed to like open a restaurant or cook for an entire like university campus cafeteria. Like these are very different kinds of scales, and things can be very different. And I think that for a long time, and this idea of like democratizing software creation has been a dream. Like many people have talked about this kind of thing, and people have actually tried to build tools for this. And one of the interesting things with a lot of generative AI tools is now we actually have the ability to do this kind of thing, whether it's vibe coding or just kind of like somewhere in between where code is being created and then you're kind of modifying it. We now have the ability to build software even if you are not an expert, or you're not an expert software creator. So you might very well be the expert in your domain, And now all the problems or ideas that you have, if they can be solved by certain types of software, the barrier to actually building these kinds of things has been drastically lowered. And so for me, it's definitely true that there are like big problems that need to be solved, but there's also this very long tail of like lots of little problems that will add up when they are solved. And this sort of like the democratization of software actually creates this like interesting agnosticism where I don't have to know what the problems are. I don't really have to know how to solve them, but there are experts out there who do know how to solve these things and actually know how to build all the software. And so whether it's like tools for building certain aspects of scientific discovery or hypothesis generation, or just even making workflows that much more efficient, these kinds of things actually add up. And there's also like there's a certain nice like delightful aspect of like people being able to build like computer games for their kids or whatever. Like there's lots of different things that are just kind of opened up. But I think that kind of democratization of software means like I don't necessarily have to know what the solutions or even what the problems are, but just the more that we can kind of do that kind of thing, I actually think it's going to have the potential for creating lots of really interesting benefits for the world.
It feels and sounds extremely empowering, because it's almost as if like you're lowering the barrier of entry for being able to create these very custom solutions for, I mean, almost anything that you want to be able to do. But now you don't have to have a degree in computer science. You don't have to understand how C++ works. You can go on to these platforms that are like either with generative AI or these no-code solutions or some other things like that. And now you can build whatever you want, which is a really, I mean, honestly, it's very unprecedented. And it feels a lot like alchemy, right?
Oh yeah, it's super weird. I mean, it's one of these like it's super exciting. And I like for me, like the closest example like from my childhood was this piece of software called HyperCard, which it came with the Macintosh beginning in like the late 1980s through like maybe like the mid to late 90s. And it was this authoring tool where you could draw and write, but then kind of under the hood, you could there was a whole language, but you could also just add buttons and kind of connect things. And so you have these different pages. It was like stacks of cards. That was kind of the terminology. And for me, like that was kind of my on-ramp to programming, but it still required a decent amount of comfort in coding. And like now, right, we don't have to anymore. And kind of and the way I kind of view it is like when I go about my day and kind of just live my life and I see interesting problems that maybe could be solved with code, I'm able to solve these kinds of things because I have a background in software. But most people who don't have that background until now, they've kind of had to say like, oh, that part of their brain, they've had to kind of like shut it down and be like, oh no, this is an interesting thing, but I can't do this. And now that's no longer true. We actually have that ability to, for everyone to kind of do these kinds of things. And and going along with like the alchemy or kind of the magical thing, like this is, and in many ways, it's sort of the kind of code itself is sort of the culmination of these desires that we've had for millennia to like use words and text to kind of coerce the world around us. And now the barrier to that magic has been drastically reduced. And actually, even if you look at like the history of magic and like how people think about it, and obviously in like our fantasy stories, like it doesn't just work. Like there's an element of craft and efforts, and like you have to go to Hogwarts for 7 years or whatever it is, and like to learn all the craft. But in many ways, but it turned out, I think in the Middle Ages, there was also this sense that like there was the magic that was for the experts, like the wizards or the sorcerers or the people who kind of knew all these things. But there was also magic for kind of the everyday user. There were like spells and things that you could, there were books with spells where you could look up like, I don't know, how to find a lost object or your lost cow or whatever it was. And then you would say something or do something. And that was for the everyday user. And I feel like this kind of democratization is the same kind of thing when it comes to sort of these, like this alchemical stuff of computing, which is pretty wild.
Absolutely. And I kind of have to wonder, because I think while it's very available, it hasn't quite saturated into the public's mind, or I guess like sphere of like the kinds of like daily activities you can do. Not yet anyways. And so it makes me think, as people become more aware of how accessible this is and make it a part of their daily lives, I have to wonder like how the world is going to change and what people are going to do with that kind of empowerment. Do you have any like thoughts or ideas about maybe what we can expect as the public is starting to explore and embrace and use these tools every day?
Yeah, I mean, so I would say, I mean, certainly like these tools are very powerful. I think we haven't quite hit on like the end version of these kinds of things. Like, so for example, um, uh, like right now we still kind of use a lot of like chat text interfaces, which is powerful, but I think combining them with certain like more graphical ways of manipulating like what piece of software looks like, there's still, this is all to say like there's still a lot of work to be done. That being said, I think when people start doing these things, and I kind of view it as sort of in the same way that like spreadsheets are kind of this like malleable piece of software that like obviously they were designed for certain kind of like office work and like manipulating data and things like that, but they've been kind of stretched well beyond those initial use cases, and people are using them for all different sorts of things. And in many cases, they're using them in a way that is actually still truly programming, where they're putting formulas and things and doing and they're just using them for, I don't know, everything from like, I don't know, helping like plan a wedding to like manipulating some other weird data set or whatever, or like analyzing some other data. It's all over the place. And I kind of view it that sort of way, where like we won't, like going forward, or maybe sometime far in the distance, like there won't be these like one size fits all kind of software. Like there will be maybe some sort of like very basic kind of platforms of software, and then everyone kind of rolls their own specific environment and like the little things that they have. And this is, and I mentioned before, like this has kind of been a long desire of people in kind of the computational sphere. And this is what people call end user programming. The idea that like the end user is actually the one programming and manipulating the world, like the kind of like computational world that they're living in. And so for me, I just view it as like, no, like, yeah, we might have to contend with like certain aspects of big tech, but by and large, I think there's going to be like a much more kind of complicated relationship between like big tech and like bespoke and little tech. And in many ways, it feels somewhat like healthier or more humane, because like a lot of these like big tech systems, they are so beyond the scale of the human that that it becomes very difficult for us to understand these things. But even separate from that, it's also like the incentives are kind of weird, or we don't fully understand kind of how they operate. Or I mean, certainly they're like, if I have a specific feature that I want, they're not gonna, like, unless there's like 100 million people that want that feature too, they're not gonna they're not gonna add it. And now I don't necessarily have to worry about that kind of thing. And I feel like it's gonna be a much more sort of like human scale kind of software, which for me feels really nice and exciting. And like, so I kind of like that, like thinking about that future. I'm not exactly sure what it's gonna look like, but that kind of human scale, human centric sort of software feels very it feels very inspiring.
It feels so, and it sounds, it feels and it sounds, and like all of it just is so empowering and beautiful, and like definitely the kind of future that I personally would like to see, where people are able to take these tools, have them in their own hands, to be able to use them for their everyday life, rather than relying on big tech to come out with an update or some sort of feature, and it's all locked behind and nothing is modifiable. And I'm honestly like, I'm very encouraged by all of this. And so, but speaking of like, inspiration and things like that, I guess what was there like an inspiring moment where you were watching all this technology develop, you were learning about code, you were studying mathematics, where you had this, maybe like, did you have an aha moment about like, wow, this is so connected to this idea of like magic? Or was it more like a gradual thing? Well, I guess like, what's the story behind that?
Yeah, I mean, so for me, I mean, I'm not so in terms of writing the book, I would say, and then I can kind of step back and kind of tell you some other stories. But like when I think about like what kind of motivated kind of how I'm thinking about some of these kinds of things, for me, like when I look at the current conversation around technology, like it feels broken, but also very foreign. So like in the sense of like there's like a great amount of like adversarial positioning towards technology, or there's worry, or there's just kind of ignorance. Like we feel very distant to a lot of technology. And for me, and it's also the kind of thing, like when we think about it, we also view it as like, okay, this is this like branch of engineering. And when I think about like my own upbringing and kind of like childhood with technology, like it didn't feel that way. It was much more, and maybe it was because of going back to this human scale, like it was a lot smaller and like weirder and kind of more delightful. So like when I thought about my family's first computer was the Commodore VIC-20, and like I can tell some stories about that. And then we like went on to Macintoshes, and it was just like my experience was like early programming and like fractals and Sim City and like screensavers versus like this like very like big tech thing of like social media that's kind of like warping our brains or whatever it is. But also it didn't, going back to like this branch of engineering, it also didn't feel like a branch of engineering. When I programmed, but also when I started learning even like theoretical computer science, it felt very connected to all these other things I was learning about, like certain ideas around like language, or certain ideas around philosophy, or biology and the nature of life, or things around art and like how we think. Like it felt very connected. And so for me, I kind of wanted, and so in writing the book, this was kind of my way of like, I kind of had to cobble together a lot of these kinds of things on my own from various different books and ideas when I was younger. And this is the kind of book that I kind of wish I had when I was first getting into computers. And so this is almost like paying it forward to like future young Sams of like, oh yeah, I kind of wish this thing was there. But like when I think about like what actually kind of create, and so for me, and there's definitely like one of the chapters I kind of talk about this, like certain aspects of like magic and sorcery and stuff like that. But there's also just the idea of like wonder and delight in computing. And I think that's something that we've kind of lost. And so for me, like when I think about like earlier, like I mentioned like the Commodore VIC-20, when we had that computer, I didn't know how to program. I was like a very little kid, like 2 or 3 or something like that, when we first got it. But I've been told like I would like sit in my father's lap as he would like enter in text from magazines or books to create a game, because like these were like, that was one of the major ways you got software. And I could see this very clear relationship between the text that he was typing and whatever happened on the screen. Sometimes it resulted in a program that worked. More often than not, it resulted in some like massive bug and like just like ASCII kind of going down the screen or whatever. But like I could see that relationship, and that was really, really, it was a really powerful and kind of wonderful experience. And then like I also had experiences like early Sim City and kind of seeing how complex systems could be embodied almost in a game form within the computer. And I found that very, very exciting. And then actually even going back to like science fiction. So this is like another experience. This is later on in kind of my computing experience. So my grandfather, he lived to the age of 99. He was a dentist, but he also was a huge fan of like learning about science and cutting edge science, as well as reading a ton of science fiction. He basically read science fiction since like the modern dawn of the genre. And I think he read Dune when it was serialized in a magazine. Like he like read all the stuff. And I remember when the iPhone first came out, I went with him and my father to the Apple store, and we were playing with the iPhone. And then at one point he just said, he's like, "This is it. Like this is the object I've been reading about for all these years." And I feel like we've like moved so quickly from like that moment of like delight and excitement to like complaining about battery life or camera resolution or whatever it is. Like we've forgotten that we are surrounded by all these wonders. And which is not to say like we should certainly be critical and thoughtful about all the technologies we have, but also being able to kind of recognize that these things are really, really exciting, I think is something worth leaning into. And so I think we kind of need that balance between kind of like the utilitarian approach of like, okay, building software that we like can use for very specific things, or building these kind of big things with like based on teams, versus like the fun little playful things that like someone is making that's like, I don't know, a computer program is art or whatever it is. We need both of these things. And I feel like at least in our society right now, we've kind of moved much more towards the utilitarian kind of like enterprise software kind of thing, and away from like the playful kind of stuff. And that's still it still all exists. We just need to almost like to rediscover that, because like there are people doing these kinds of things, like making weird things online, or making like programs that are kind of like artworks, like creative code, or doing weird things like at the intersection of life and biology, obviously. But we just need more of that. And so like for me, it was, yeah, I don't think there was any single moment. I've kind of tried to give you like a few little moments, but like it was kind of this slow burn of realizing that all the things that I think about are sort of connected to code and computing. And it's almost this like, it's kind of this like weird, all-encompassing humanistic liberal art, at least when looked at from some weird angle. And I really just wanted to share that with more people, or get more people to think about it like the way I think about it.
I love that. And I completely agree, because I honestly, I often think about this, where it's actually quite incredible how much we take for granted in our everyday lives, just simply because it's common now. I mean, I'm always thinking about if I were to, or we were to take some technology to the past, like 500 years ago. I mean, heck, even 100 years ago. But it's even fun to think about it doing like 300,000 years ago to very early humans, and being like, look at this thing. I mean, it's literally alchemy. Like that person is a wizard. Like, they're a magician. They have this piece of like, I mean, really, magic is the only word for it. And I always find it really interesting, like with your example with the iPhone. I mean, that moment when it was like, because I remember it too. I mean, so I was in high school when our first, somebody in our class had the first iPhone at our school. And I just remember looking at it, and we were all crowded around, and we were amazed. It was a iPod, it was a flip phone, it was a calculator, and it was a camera, all in one device. And then he was like, oh, you can go to the App Store and you can see, like, you can make it even more things too. And I was just like this all, I couldn't believe that you didn't have to have all these little devices anymore. You can have one device, because you could code things. Like, you can create a magical device, and then with code, you can make it do so many different things. That just blew my mind. But now it's just like, that's just, everybody has a smartphone, and it doesn't blow anybody's mind anymore, and it's just like a commonplace thing. And so it's a very interesting world that we live in, I think, because of how quickly technology saturates our everyday life like this. And, I really appreciate that you're taking the time to say that, maybe we should appreciate that more, right? But I'm also wondering about things like, what can we do in our everyday life, I suppose, to kind of take a step back and, I don't know, like, appreciate the things that are like this amazing, like, technology that's around us, and really get that sense of wonder again. And really, I don't know, like, I guess, is there something that you do in your everyday life to where you really ground yourself in that kind of perspective?
Oh, I love that idea of it. I'm not sure I do. I mean, one of the, I'll say a few things that kind of that I was reminded of as you were talking. I mean, one, when you were talking about like the iPhone, taking it for granted, there was actually this amazing visualization. It was like a little like short video or whatever, and maybe just watching this video is one way of doing this kind of thing, where it shows like a desk from like, I don't know, 1980, of like all the different things that are on the desk, and then slowly each thing on the desk becomes like an app on the phone, and like it's this massive process of like dematerialization, where it's like, I don't know, like, there's the globe and it becomes, or like, and then there's the Rolodex and the calculator or whatever. I forget exactly the different things. And it was just unbelievable to see all these different things. Maybe they're going onto a computer instead of the phone. I forget exactly what it was. But just seeing those kinds of things, I think, is really powerful. And so, and I would say, I mean, related to like, I mean, how people adapt to this. On the one hand, it's very good that humans are actually very fast at adapting to things. So I think that's a good thing. In terms of how to, I don't know, rekindle that wonder or that excitement. I mean, some of what and one of the things I actually do is I read a lot of history of technology, and like reading the history of technology can give you that sense of like how far we've come. But I also think, I think actually understanding the history of computing and the history of technology more broadly is really important for a lot of different reasons. One is I think it rekindles that wonder. It just is kind of like the first pass of like recognizing how far we've come and all the things that we kind of like, we sat on the shoulders of giants. But in addition to that, when I look at like the world of Silicon Valley and just like the tech world, that world, it's very like present and future focused, and which means and so there's like a great deal of ignorance of the history of technology, and sometimes like there's a certain amount of proud ignorance, which is like that's a whole separate thing. But due to that ignorance, like, people don't realize, right, not only how far we've come, but the fact that things are not necessarily nearly as new as we might expect. Like the reason we have certain things is certain, like there's like complex path dependence, or there are things that people think are new, but actually we're just kind of revisiting old ideas. And because the truth is, like, you look at like old computer magazines, and like obviously the language models and the neural network systems that we have now are qualitatively different, or at least quantitatively different. But like these things are not wildly, like you could like look in these old computer magazines and like there were advertisements like buy simple neural network software in like the 1980s and the 90s. Like these things are like they were just around. And so for me, just kind of looking at the history of technology kind of helps ground me in terms of like understanding that we have made a great deal of advances, but also at the same time, the questions we've been posing and the kinds of solutions we've been thinking about, they're not necessarily radically new. And so like when you look at like the current discussion around AI, around like issues of like alignment or unanticipated consequences or job disruption and things like that, and they're very good conversations to have, but people were having these conversations like decades earlier. So like you look at, so Norbert Wiener, the creator of cybernetics, he has this small collection of essays. I think it was based on a series of lectures called God and Golem Incorporated. And then he like anticipates all those things we're talking about. But the truth is, it wasn't even just like some weird little area of like cybernetics. In the 1960s, like one of the, like in the original Star Trek series, like one of the original episodes was this episode called The Ultimate Computer. And it was exactly about all these issues. Like they talk about alignment and job stuff and like all these things. And just to see that we are like almost just like recapitulating a lot of these conversations, sometimes in ignorance of realizing the kinds of things that people have asked and the questions people asked or some of the answers people have posed, I just feel like we can do a lot better. So for me, like looking to like history, I think can be really, really powerful in so many different ways.
It makes a lot of sense. And those old computers were so much fun. I mean, I remember having on our first family computer that my parents bought, we did get one of those very early neural networks, and it was advertised to say that it would help your computer talk to you, and then you could interface with the computer by talking. But of course, data was a big limitation. So the caveat was you had to spend hundreds and hundreds of hours training it to speak. And I remember my dad doing it and just sitting there in front of the computer being like, hello, hello, hello. And then like it would like make weird noises and it would be like,
I love this. Right. Because like I remember I remember my father being very interested in those software, like those applications. I don't think we ever got one because I would definitely have remembered that long, laborious process, like watching him do that. But that stuff is, right. Like these things they were around. And obviously what we have now is different in many, many different ways. But even like going back to like the democratization of software, like these kinds of things, like they've been in the air for decades, or like ideas around and even obviously like artificial life kind of stuff. Like these things have also been around for a very long time. Like, and the truth is most of the things actually that I discuss in the book, The Magic of Code, but also just more broadly, like most of the things that we use computers now for, like they were used almost at the very inception of like modern digital computers. Like I think it was the Institute for Advanced Study, like one of their machine, there was like some early artificial life experiments. These things were used for large scale simulation. There were like early like and not quite democratization of software, but like tools for thought kind of stuff being done maybe in the 60s or 70s, or maybe like all these things were around, and and even like AI, like the term artificial intelligence was like 1955, 1956. These things have been around for a long time, and like it takes a while for them to like germinate and mature. But like it, yeah, looking back to these histories and seeing what people have been thinking about and doing, can be really powerful, and also very humbling to realize that nothing is quite as new as we think it is.
Yeah, and actually this is related to this question that we have in the Slido from Georgie. And he is curious about this idea of digital literacy. He's saying it's an old idea of digital literacy. And he's saying that it seems to decline over time, especially for Apple users, because it's easy and it's locked. I guess I'm wondering, like, do you see a trade-off between having things that are so, I guess, like easily accessible in terms of coding, but do we also see, like, do we see a trade-off between that and our ability to understand what's happening behind the scenes because of, maybe we're not as familiar with like the history, like we don't see things the way that old computers used to show us. What are your thoughts about that?
Yeah, I mean, computers, there's always like many, many layers of abstraction. So like there's always a trade-off. Like we're never going to go all the way down to like the base, like the bare metal or whatever it is. That being said, I definitely agree that like we need greater means of like peeking under the hood. Because I think like when things are very sophisticated, but also kind of hermetically sealed, like we don't really have a sense of like what's going on underneath. And so for me, like when I was mentioning like with like the early Commodore, like Commodore VIC-20 and like these type-in programs, like the fact that I could see the relationship between the text my father was typing and what was happening on the screen was really, really enlightening to me. And we've kind of lost some of those kinds of things. I think maybe with certain aspects of like generatively, like computationally generated code, that like maybe we'll get some of the way back there. But I do think we need better and more ways of like peeking under the hood. Like it can be as simple, maybe like status bars or like very simple, like progress bars are like very simple, but like, and the fact that like every Macintosh still has like it's a Linux variant, or it's a Unix variant. And it's like there's like the terminal under the hood, like you can pull it up and like I have it have it in my dock, and like so like these kinds of things I think are good starts. Like we definitely need more ways of doing that, because for me it's also the way I think about it is the digital, going back to like the digital literacy. In addition to digital literacy, like there's just like we need an awareness of like the vast complexity of the technologies that are around us. And I think when these things are kind of sealed off, we lose that. And so one of the stories I love telling is like when the Apple Watch first came out, and it was like soon after the Apple Watch came out, there was this article in, I think it was the Wall Street Journal, the style section, around like whether or not people are still going to buy mechanical watches. And they're talking about it and like, well, like the upsides, downsides, and like, yeah, people are still going to buy mechanical watches. But they interviewed this one guy, and he's like, yeah, like, of course I want a mechanical watch. I think about a mechanical watch, it's so complex as opposed to a smartwatch, which is just a chip. And I'm thinking like, just a chip, like this thing is like orders of magnitude more complex, but we've been shielded from it. And for me, like oftentimes the only time we see that complexity is when like we have like glitches and failures and like something goes wrong. And then we're kind of like blindsided by the vast complexity of our technologies. And so for me, like just finding ways of making people more comfortable to like learning and understanding these different technologies, I think is very, very important. I think having, luckily, like I think in most systems, there are ways of kind of like digging a little bit under the surface. Right now, it's a matter of like really wanting to do that. And clearly most users are highly incentivized to like never do that kind of thing. But if people can just like, maybe feel a little bit more comfortable digging, like peeking under the hood, or maybe making it a little bit easier, I think that kind of digital literacy is going to be very powerful. But it's like going back to like the layers of abstraction. Like we're never going to get all the way to the bottom, but just feeling comfortable going like one layer below what you would normally do, I think that's like the first step. But yeah, we definitely need more of it.
I agree, because it's also very inspiring as well. I mean, like, I remember when I was learning about the different architectures of how computers work and how we're pretty much just using one type of architecture. I kind of really started to think about, like, well, what kind of other architectures can we use, and when should we use this one versus this one? What are the pros and cons? What situations would they be stronger? So my hope would be that by understanding what's going on under the hood, people can gain some inspiration about things to build that are completely different from what we would see today.
Right, yeah, just like giving you a sense of like, yeah, like that like space of possibility. And actually going back to like that history, like the history piece, like we we really quickly kind of like got stuck in certain paradigms. Like those paradigms work really well, but being able to like understand that history or understanding that kind of path dependence allows you to say, oh, maybe there are other paths worth exploring, and like seeing like, yeah, what are these paths not taken? What are the things that we should be trying? And you can only gain that when you have an understanding of like a little bit of like what's going on under the hood. I also just think it's like it's also incredibly like I don't know, just like awe-inspiring to like recognize like computers are fundamentally like at their very base they are very like it's a huge number of pieces that are each individual piece is very simple, but when you have enough of them together, oh my god, like you can do things that just kind of boggle the human mind, and that's wild.
Exactly. It's crazy. And
Yeah.
so there's a question in Slido that I find really cool and very related to this. So what would the Lovecraftian in you say about summoning unknowable digital gods through code we cannot or no longer understand?
So, oh, I like this a lot. I think. I mean, we are already there. Like that. That's one of these things. Like we are already, like to a certain degree, like living in this kind of like Lovecraftian world of our own making when it comes to technologies. And most people just don't want to realize that. And so the computer scientist Danny Hillis, he talks about how we've kind of moved from like the Enlightenment, we can kind of apply our rationality to understand the world around us, to the entanglement, where everything is just so hopelessly interconnected, we can't hope to understand it fully. And it's actually so my second book was called Overcomplicated. It was all about sort of the incomprehensible technologies of our own making, and which is one of these things where like you just realize they are everywhere. And so to a certain degree we are in this Lovecraftian world where we're kind of just like, yeah, slowly paddling on this dark sea and things below us are like these kind of like crazy creeping monsters and horrors that we can never imagine. That sounds really negative. It's not quite like that, but I would say it's, for me, it's like I think it's one of these things where if we think as humans that everything we build is entirely logical and understandable, then when we are confronted with things that are not quite like that, it's going to be very demoralizing, versus saying, no, I mean, we spend a lot of our time already as humans just dealing with systems we don't fully understand, which are just biology, like other human beings or even ourselves. Like we don't fully understand them, but biologists, they are able to slowly but surely kind of make headway in understanding like certain parts of systems or like certain subsystems or whatever it is. And for me, like understanding is not one of these. It's not a binary condition. Like either we have full and complete understanding or complete utter ignorance. And so, and like there's this like very complicated spectrum that we can kind of move along. And obviously, moving towards greater understanding is good, but in some ways, it actually requires kind of like changing, like moving away from like the kind of enlightenment kind of rationality mindset of like being able to understand everything, versus like there was, I mean, in the Middle Ages, and there was somewhat of an idea of like it was like there were things we were never going to understand, and it was like so like for example the philosopher and physician and Rabbi Moses Maimonides, in his book the Guide to the Perplexed, he actually talks about like there are things we will never understand that are kind of like only in the mind of God or whatever he's talking about. He actually gives a list of like, here's a whole bunch of things we'll never know, which is kind of crazy. And like, but he was totally okay with it, like because he recognized like the human mind is limited, and I think recognizing that when it comes to just like the fact of like any large complex system with a huge number of interacting parts, like there are ways of gaining understanding into them, and I think that's very important, very powerful. But we're never going to be able to hold all those components and their interrelationships in our head at any one point. And that's fine. And sometimes we can actually use other systems to help us understand these things, and sometimes those systems we ourselves don't fully understand. And so there is definitely going to be some weird like human machine partnership in understanding these kinds of things. There definitely can be a certain amount of like Lovecraftian horror in that, where like we're relying on Lovecraftian monsters of great complexity that we have summoned to understand other systems. And like you can, there's ways of making it sound really, really bad. I don't actually think, maybe it's I'm like temperamentally more optimistic or more positive. And so I think this is the kind of thing where it's like it's we're already living in this world of systems we can't fully grapple with. It's more just a matter of like being very aware of that and then deliberate in how we approach and perceive these systems and just try to better understand them. And for me, it's like the two approaches that are bad when it comes to like recognizing these systems is either like cowering in fear or like worshipful awe. Because the truth is like, first of all, these things should not be worshipped because they are systems built by humans, since they're going to be imperfect. And so both awe and fear, they cut off questioning and curiosity and further learning. And so that kind of humility of saying like, it's okay if we don't fully understand things, but it's still worth trying. That's the only approach that really keeps on allowing us to actually question and try to understand things further. And so that I think is the more positive approach. But we are definitely there, like summoning Lovecraftian monsters. Now the question becomes whether or not we can find any way of meeting them halfway.
Yeah, and I read or heard once about an example of an airplane, like a Boeing 707, 777, any airplane really. And like these machines are so large, especially the ones that carry like 500 passengers, that even though it's created by humans, not one human can fully understand it enough to build it from scratch, which is in some sense to one person like a Lovecraftian like horror that nobody can understand. And yet, as a group of people, we can all understand it together because of how we democratize. Well, in that sense, like the knowledge is democratized within a group across the different factory workers and the engineers and the scientists and the people who put the plane together. So in that sense, it kind of makes me think that, even if we don't understand things on an individual level, if we can understand things on a society level, maybe that's gives people a little bit of comfort who might be a bit afraid and are worried about not necessarily understanding things as an individual.
Yeah, and I think exactly what you're saying is correct, which is like, right, like we have this kind of like civilizational, like distributed knowledge that I think allows us to do many things that like, yeah, no single person could ever do. Like I think there was one guy who tried to actually build like a toaster from scratch, and it was like he eventually did this, but he like involved like smelting and like all these processes, and like it was amazing that he was able to learn all that kind of stuff. But the beauty of a like complex civilization is we don't have to do that kind of thing. Like there are these kind of distributed bits of knowledge, and actually, and the same thing is kind of in the computational realm, which is, and going back to this idea of like abstraction, like when we build things upon successive layers of abstraction, we essentially don't have to worry about the things below it. Sometimes you do, and that's a whole separate situation. But by and large, we don't. We can actually abstract away those details and then build things where we're not constantly recapitulating everything from scratch. And that's enormously powerful and inspiring. And so for me, right, like in one sense, like even when you build like some, like, I don't know, like some little Python script that draws in different libraries and things like that, you are maybe summoning Lovecraftian monsters that you don't fully understand. But in other ways, like that's exactly how computer science works. Like that's what we want to do. Like in this case, it's like maybe we don't fully understand it, but as long as we understand the abstractions and the interfaces and the way things work, that's all that matters. And so, yeah, maybe the Lovecraftian thing is the wrong analogy there, but I think like that kind of abstraction stuff, I think is really, really powerful in helping to actually manage a lot of that massive complexity.
That's a great point. And I love that because, I mean, at the end of the day, that's what we do as humans is we abstract things. Like, I guess that is what makes our science and our technology so powerful is that we're able to describe things in very short, I guess, like lines of descriptions with, oops. Oh, okay. Sorry. I thought it cut out for a second, but yeah, it's like that's what we're able to like. That's where our power comes from. I think is this ability to shorten our descriptions of things, so we don't have to explain everything in terms of like how every atom is moving and the momentum and position of each like exact particle.
Right. There's like right. We can compress things. We can use higher level concepts. Like there's all these different things that we've developed as a society that that allow us to actually grapple with these ideas and technologies and scientific advances that otherwise we'd be hopeless.
Mm-hmm. Absolutely. And so Olaf's comment on the Slido talks about how you close the book with the People's Computer Company, this idea. So can it address our current critical computational moment in what we're seeing with, especially with like LLMs and neural nets and AI? And how do you see it? And what do you think its structure should be or is going to be?
Yeah, and so what Olaf is referring to, so the People's Computer Company, it was this. It wasn't really a company; it was like a newsletter, and I think there was a physical space where they taught things about computing. But it basically, and so their motto, and I don't fully remember it off the top of my head, but it's something to the effect of like computers kind of like are for people, and like that's kind of like the goals, like they need to kind of be for people, and kind of bringing in that kind of human like level, like the human scale, kind of what we were talking about earlier. And obviously, yeah, with these like AI systems, they are very far from human scale. And so when I think about how we think about all these technologies and computation more broadly, I think the path of least resistance is saying, okay, let's make these systems bigger and more powerful and more interconnected. And in some situations, like that's not necessarily the wrong idea. Like there is a great deal of power in that kind of thing. But for me, like when I think about like it's like what the future holds is not just taking like the last few data points of whatever we've been doing and just kind of like drawing a line and saying like, oh, now it's going to continue going this way. Because then it becomes this idea of like, oh, what is technological advance? It's simply just like it's like this progress pixie dust that we're just kind of like sprinkling over everything, where everything is just kind of moving forward. It's not because like technological advancement is not, it's not this like wave that's washing over us. It's ultimately a series of choices that we are making as humans, as a society, of like what to do. And so for me, it becomes imperative to say, okay, what is the world that we want to live in? And then let's work backwards from there and figure out what are the choices and the decisions or the technologies that would actually make that kind of world more likely. And so when I think about a world where humans ultimately are the best versions of themselves, in some aspects, maybe that fits kind of the trajectory we're on. In other ways, it doesn't necessarily. And I think we just need to be very deliberate about thinking about where like computers kind of can make us better versions of ourselves and allow us to do our like the things we want to be doing already better versus not. And so, and actually another going back to computing history. So there's this great TV show called *Halt and Catch Fire*, which is it's about sort of like the early kind of personal computing industry. And so I think it like starts in like 1980 and goes to like the early to mid 90s. And I think it might even be the first episode. One of the characters says, they're talking about computers, and it's like, the computer is not the thing. It's the thing that gets you to the thing. When the idea is like when we think about computers as an end for themselves, we often you just kind of make them faster and faster and faster versus saying, no, what is their goal? Like, what is the thing we want to get to? Is it allowing us to think better thoughts, allowing us to like live more balanced lives, or like build software that is more in tune with our needs, or allow us to do like the things that we want better, like whatever it is. That's really ultimately what computers are for. And there are a number of people who are like playing with these kinds of things, and so there's people who are talking about like kind of like a physically like a the computer is like a physical space where you're kind of manipulating paper and programs and things like that, where you're almost doing things with other people. And so it's like Brett Victor's Dynamic Land, and there's a Folk Computer by Omar Rizwan and Andres Cuervo. There's a number of people kind of thinking, like really trying to rethink what computing could look like. And for me, it's, I don't have a clear sense of what it's going to look like. Maybe I have a clear sense of like what it should feel like, and it should feel like it should feel like not kind of by itself. Like it should feel kind of embedded in all the other human things that we do. Kind of going back to what I was saying, like computers as this kind of like, or computing as this like humanistic liberal art that like connects to biology and language and philosophy. Computing also should be deeply embedded in all these things, but also in a way that makes me feel like, oh, like I'm not just choosing between like my screen existence and my physical existence, and like these things can, like, there's not an either or. Again, I'm maybe not kind of posing that as well as I could, but that's a long way of saying, with the directions of AI and where they're going, I can definitely see some things that feel very out of whack when it comes to that. I can see some things that are more kind of in line with that, of like maybe making us like creative versions of ourselves, but I can also see many futures where it kind of eliminates all human creativity. And so really it becomes one of these questions where, and this is actually one of the things I discussed in the book, where around this idea of like, it's less about figuring out what's uniquely human, because whatever we think is uniquely human that AI can't do, like 10 minutes later, AI can do that. It's much more about saying like, what is quintessentially human? Like, what are the things that I value doing, even if other people or other animals or other computers are able to do those kinds of things? So like, I don't care that, like, so like, for example, like my son, like when he plays chess, he does not care about the fact that AI is superhuman at playing chess, because he just enjoys playing chess. And so if he had a program that played chess for him so he didn't have to play chess, that clearly is like, that's missing the point of what computers can do. Like if there's software that allows him to like level up his game or learn more, then that's great. But ultimately, if playing chess is the thing you want to do, or spending time with your family, or thinking better, or writing, like it's all a matter of like figuring out like, what are the things that are quintessentially human to you, what gives you meaning, what kind of makes you the best version of yourself, and then finding the kinds of technologies that empower you that way, as opposed to limiting those kinds of abilities.
I think that's absolutely phenomenal. And honestly, like, I think that like that, all of that, what you said, I was just thinking about it, and I was like, what an amazing way to reframe and bring us back to what computers should be. And the whole reason why we have them, it's to get from point A to B, rather than about the computer itself. And I think that you did an amazing job pointing out that, you know, by putting computers back into this perspective, this is what technology is supposed to be for. This is why we're developing it. And I think you did a really great job on that. And honestly, I think that's a perfect end to this conversation. It's like, wow, that's great.
Thank you very much. Thank you, I appreciate it.
Thank you so much, Sam. This was a fantastic conversation, and I had so much fun.
Likewise, thank you so much. This is wonderful.
Do you have anything that you would like to add at the very end? Any last notes?
No, I feel like I kind of got out a lot there from like that last like monologue, so I feel good. But if people are certainly interested in kind of more of that kind of approach, my book kind of goes into greater detail about all these kinds of ideas, but sort of with that kind of same philosophical approach.
Amazing. Magic of Code. Thank you so much for joining us today. Thank you so much, Sam. Thank you, everybody on YouTube Live. And thank you, everybody, for participating in the discussion. And of course, thank you for everybody who are watching us far in the future, close in the future, and very far in the future. All right. So don't forget to like and subscribe so you'll be the first to know about our next great Crossroads event. We'll see you next time. Bye.